The universe has always been a source of fascination, full of mysteries and phenomena that continually challenge our understanding of existence. One of the most captivating objects of study is our neighboring galaxy, Andromeda. Known for its breathtaking beauty and immense scale, Andromeda is not just a tranquil sight in the night sky. It is a dynamic, powerful entity with a history of devouring smaller galaxies and is currently on a collision course with our Milky Way. Recent observations by the James Webb Space Telescope have once again turned our gaze toward Andromeda, revealing astonishing details that hint at the cosmic drama unfolding between our galaxy and its nearest neighbor. Our understanding of Andromeda and the broader universe has been shaped by a series of revolutionary discoveries over the past century. In the early 1920s, astronomy was still in its infancy. The technological advancements in electrical engineering had significantly enhanced telescope capabilities, allowing astronomers to peer beyond the edges of our Milky Way for the first time. This era marked a turning point in our comprehension of the universe's vastness. At the forefront of this transformation were astronomers like Heber Curtis, Harlow Shapley, and Edwin Hubble. Curtis and his contemporaries initially believed that the Milky Way constituted the entire universe. However, Shapley suspected that the universe was much larger and contained numerous other galaxies. This idea was revolutionary, challenging the prevailing belief that the Milky Way was all there was. During this period, strange nebulous clouds were observed beyond the Milky Way, one of which was the Andromeda Nebula, so named because it lay behind the Andromeda constellation. At that time, Andromeda was considered a mere nebula, a curiosity outside the bounds of the known universe. However, in 1924, Edwin Hubble made a groundbreaking discovery that forever altered our understanding of the cosmos. Hubble proved that Andromeda, along with several other nebulous objects, was not just a cloud of gas and dust but a separate galaxy in its own right. This discovery expanded our perception of the universe, revealing that it was far larger and more complex than previously imagined. Just a century ago, the realization that other galaxies existed was a profound shift in human thought. It was as if the universe had suddenly grown exponentially, dwarfing the significance of our own galaxy. This discovery was akin to the earlier shifts in understanding when humanity learned that the Earth was not the center of the universe or even the solar system. The expanding universe concept led to further exploration and discovery, revealing a cosmos populated with billions, if not trillions, of galaxies. Today, we understand that Andromeda is a colossal spiral galaxy, much like our Milky Way but significantly larger. With a diameter of approximately 220,000 light-years, Andromeda is nearly twice the size of the Milky Way, which spans between 100,000 to 120,000 light-years. Andromeda is home to an estimated 1 trillion stars, compared to the Milky Way's 100 to 400 billion stars. This high star density makes Andromeda a beacon in the night sky, visible to the naked eye from Earth even though it is 2.537 million light-years away. The discovery that Andromeda was not a mere nebula but a full-fledged galaxy was not only a testament to the technological advancements of the time but also a humbling reminder of our place in the universe. If Andromeda, a galaxy twice the size of our own, was just one of many, how vast must the universe be? Modern estimates suggest there are about 50 billion galaxies in the observable universe, with some calculations putting the number as high as 2 trillion. This realization has opened up new fields of study and deepened our understanding of cosmic structures. Andromeda's vastness, its trillions of stars, and its complex structure are a testament to the dynamic processes that govern galaxy formation and evolution. The galaxy's spiral arms, rich in gas and dust, are sites of intense star formation, where new stars are born from the remnants of old stars and the interstellar medium. The James Webb Space Telescope, JWST, the most powerful space telescope ever built, has provided us with unprecedented views of Andromeda. With its razor-sharp infrared imaging capabilities, JWST can peer into the heart of galaxies, uncovering details that were previously hidden from view. Unlike the Hubble Space Telescope, which primarily observes in the visible and ultraviolet wavelengths, JWST excels at capturing infrared light. This capability allows it to see through dense clouds of gas and dust, revealing the underlying structures of galaxies and the processes occurring within them. When JWST turned its gaze toward Andromeda, it unveiled a galaxy teeming with activity. One of the most striking features revealed by JWST is the presence of dust rings within Andromeda, structures that have remained hidden in other wavelengths. These dust rings are crucial to understanding the galaxy's history of star formation and the dynamic processes that shape it. Infrared observations allow astronomers to study these structures in detail, providing insights into the life cycles of stars and the evolution of galaxies. JWST's observations have also shed light on the cooler objects within Andromeda, such as young stars and regions of star formation. These objects do not emit enough heat to be visible in the traditional light spectrum, making them difficult to detect with previous telescopes. However, JWST's infrared instruments can pick up even the faintest traces of light from these objects, allowing us to study them in unprecedented detail. The ability to peer through the dense dust clouds that obscure the central regions of galaxies has opened up new avenues of research. For the first time, we can observe the inner workings of galaxies like Andromeda, studying the interactions between stars, gas, and dust on a scale that was previously unimaginable. These observations are helping astronomers to build a more complete picture of how galaxies form, evolve, and interact with their environments. While Andromeda is a sight to behold, its beauty belies a darker nature. Andromeda is what astronomers refer to as a galactic cannibal. This term describes a process where a larger galaxy, through its gravitational forces, absorbs the material of a smaller galaxy, effectively devouring it. Unlike a galaxy merger, where two galaxies combine to form a new, larger galaxy, galactic cannibalism involves the destruction of the smaller galaxy, leaving the larger one relatively unchanged. This process has been observed in galaxy clusters, where galaxies are packed closely together. The gravitational interactions between galaxies in these clusters can lead to the disintegration of smaller galaxies, with their stars, gas, and dust being pulled into the larger galaxy. The Andromeda Galaxy has a history of such cannibalistic behavior, having devoured several of its satellite galaxies. Evidence of these violent acts is seen in the structure of Andromeda's stellar population and in the remnants of smaller galaxies like M32 and M110, which still orbit Andromeda today. Interestingly, the Milky Way is not innocent in this cosmic drama. Our galaxy, too, has a history of galactic cannibalism. It has absorbed several smaller galaxies over its lifetime and is currently in the process of devouring the Sagittarius dwarf galaxy. This process of galactic assimilation is a key driver of galaxy evolution, contributing to the growth and development of galaxies over time. Galactic cannibalism is a reminder that the universe is not a static place but a dynamic and ever-changing environment. The interactions between galaxies, whether through mergers or cannibalism, play a crucial role in shaping the large-scale structure of the universe. These interactions drive star formation, trigger the growth of supermassive black holes, and influence the distribution of matter in the cosmos. The most dramatic event in the future of our galaxy is the inevitable collision between the Milky Way and Andromeda. Currently, Andromeda is hurtling towards us at a speed of about 110 kilometers per second. This cosmic rendezvous is expected to take place in approximately 4.5 billion years, leading to a merger that will transform both galaxies. This event, often referred to as the Milk-Dromeda collision, will be a slow, gradual process spanning millions of years. As the two galaxies draw closer, their gravitational fields will begin to interact, causing dramatic changes in their structure. The outer stars of both galaxies will start to collide, their orbits perturbed by the gravitational forces of the approaching galaxy. This will lead to a chaotic yet beautiful arrangement of stars, with some being flung out of the galaxies entirely, drifting through intergalactic space. The collision will also trigger a new wave of star formation as the gas and dust within the galaxies are compressed. This process will give rise to bright, young stars, creating a cosmic fireworks display as the two galaxies merge. However, not all of the interactions will be harmonious. In some regions, the immense gravitational forces will cause significant disruptions, leading to the destruction of star systems and the formation of new structures. At the heart of both galaxies, the supermassive black holes will engage in a cosmic dance, gradually spiraling towards each other as they orbit in an ever-tightening embrace. Eventually, these black holes will merge, releasing vast amounts of energy in the form of gravitational waves and high-energy jets that will shoot out into the surrounding universe. The collision between Andromeda and the Milky Way, while inevitable, will not be as catastrophic for individual stars and planets as it might initially seem. Despite the vast number of stars in both galaxies, around 1 trillion in Andromeda and up to 400 billion in the Milky Way, the actual probability of stars colliding is extremely low. This is because, on a cosmic scale, the space between stars is immense. Even in the densely packed cores of galaxies, stars are separated by such vast distances that direct collisions are rare. However, the gravitational effects of the collision will be profound. As the galaxies begin to merge, the gravitational pull will disrupt the orbits of stars, potentially ejecting some from their galaxies and sending them into the void of intergalactic space. This phenomenon, known as gravitational slingshot, will leave some stars to wander the universe alone, without a home galaxy. Others may be drawn into new, more elliptical orbits, fundamentally altering the structure of what will eventually become the Andromeda Galaxy. The impending collision between the Andromeda Galaxy and the Milky Way will lead to a gradual merging over billions of years, resulting in a new elliptical galaxy, often referred to as Milkdromeda. Despite the immense scale of this event, individual star collisions will be rare due to the vast distances between stars. The collision will reshape both galaxies, distorting their spiral arms and triggering new star formation, while also merging their central black holes into an even more massive one. Over time, this new galaxy will evolve and become increasingly isolated as the universe continues to expand, marking a significant chapter in the cosmic story. If you've enjoyed this deep dive into the cosmic drama unfolding between the Andromeda Galaxy and our Milky Way, make sure to hit subscribe and stay tuned for more fascinating insights into the universe's most incredible phenomena. The journey through the cosmos is full of surprises, and there's always something new to discover. Thanks for watching.